Okay, so the theorem 4, if each pair of opposite side of a quadrilateral is equal, then it is a parallelogram, right? So this is the converse theorem of the previous theorem, which we have done in the last class, right? And now let's see how to prove this. So very first, we should write like what is given. Okay, so given is a quadrilateral, right? Whose opposite sides are equal. This is given, isn't it, Rudra? Are you getting it? Right? So
Yes,
this
ma'am.
is given. So just write down a quadrilateral ABCD, right? Okay, so just draw a quadrilateral here. Suppose there's a quadrilateral, right? Okay, AB, CD, right? And in this, AB is equal to CD because it is given opposite sides are equal, right? AB is equal to CD and AD is equal to BC. This is given. This equal to this and this equal to this. Now we have to prove that ABCD is a parallelogram. So they are equal, this is given, but they are parallel, it is not given, right? So we have to prove that they are parallel also, right? Now, here we need to do some construction, right? What we do, we draw a diagonal, right? Suppose let's take a diagonal here, AC, join AC to form the diagonal, right? Join AC. This is the construction we have made, right? Now, proof. In triangles ABC and triangle CDA. So you can see that this diagonal divides the quadrilateral into two parts, ABC and CDA, isn't it? Are you getting that? Alisha, Rudra, Anvi, right? And in these triangles, some sides are already given equal, right? AB is equal to CD. This is already given in the question, right? This side is given equal to this side, right? And BC is equal to AD. This is also given, right? Okay, this side is given equal to this side, right? Okay, and if you see AC is equal to AC, this is a common side. Yes or no? This is a common side, rather say CA. This is equal to CA. This is the common side between the two triangles. This side is common, yes or no? Rudra, are you getting this? So this is a common side between the two triangles, right? Okay, so we can take this, that this is common. So by these three things which are equal, three elements are equal for the two triangles, right? So three sides are equal. We can say that triangle ABC is congruent to triangle CDA. Okay, ABC is congruent to triangle CDA. By which criteria? By SSS, side, side, side. Okay, by SSS congruence criteria, right? So by using this congruence criteria, we have proved that the two triangles are congruent. Now, since these two triangles are congruent, can we say that angle BAC, this angle, is equal to CDA? Sorry, DCA, yes or no? This angle, they will be equal, right? Okay, angle DCA, right? Okay, because for two congruent triangles, by CPCT, we can say that corresponding parts of the congruent triangle base are equal. So by CPCT, we can say that angle BAC is equal to DCA, right? And if you look at these two angles, these are alternate interior angles, right? Yes or no? So these are alternate interior angles. Alternate interior angles where the two lines AB and CD is cut by the third line AC, where AC is the transverse, right? Okay, so when the two lines here, if you can see AB and CD, this is cut by the third line AC, and therefore these two angles are alternate interior angles, which we have proved that they are equal. Since alternate interior angles are equal, we can say that AB is parallel to CD. Okay, right? Because जब alternate interior angles equal होते हैं, तो lines parallel होती हैं, right? So by this we can say that AB is parallel to BC. Right? So one thing we have proved, right? Similarly, we can prove that AD is parallel to BC, right? By AD is parallel to BC, right? Yes or no? Okay. Again, the two triangles are congruent. They are alternate interior pair of angles. Other pair of alternate interior angles between the two sides AD and BC. Now this time we will take these two sides, this and this, which is cut by the third side AC, right? So alternate interior angles, right, are equal. That means this angle is equal to this angle, which are alternate interior angles, and therefore AD is parallel to BC, right? So same thing you have to write down in the other part, right? And that's how we can say that AD is parallel to BC. This is your second one, right? So since AB is parallel to DC and AD is parallel to BC, right? Opposite sides are parallel. Hence, we can say that ABCD is a parallelogram, right? So we have proved that ABCD is a parallelogram. Is that clear? Rudra getting this? Rudra
Yes,
getting
ma'am.
this?
Yes, ma'am.
We get
Okay.
AD equal.
So now this theorem 5, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram, right? So we have to prove that for a quadrilateral, if diagonals are bisecting each other, bisecting means the diagonals are bisecting each other means dividing themselves, right? Okay, into two equal halves, then it is a parallelogram, right? So first we will draw a parallelogram and write down what is given. Given is a quadrilateral ABCD, as you can see in the figure, right? And the two diagonals, let's draw the two diagonals. This is the diagonal AC and this is the other one, right? Okay. So quadrilateral ABCD is given, okay, and AC and BD, these are the two diagonals which are intersecting, suppose at a point O, right? Okay. So AC and BD intersects at O, right? And how they're intersecting? Such that they are bisecting each other, right? Means OA is equal to OC. This is equal to this, okay? And OB is equal to OD. Means this is equal to this, right? So they are intersecting each other in such a way that they are equal. This is already given. The diagonal of a quadrilateral bisect each other. Means they are dividing themselves into two equal halves. Okay. Then we have to prove that. So to prove that ABCD is a parallelogram, this we have to prove here, right? Now, proof. What is the proof now? So as you can see this figure, there are two triangles which are formed in triangle OAB and triangle OCD. OAB, this one, and OCD, this one. Right? We are considering these two triangles. Getting that? Now in these two triangles, what we have? What we have in these two triangles, if you look at with carefully, right? OA is equal to OC, right? OA and OC are equal, right? Okay, this is already given. OB is equal to OD, right? So this side is equal to this side, right? This is also given, right? So these two sides already given, and the angle, this angle is equal to this angle. Yes or no? Why? They are vertically opposite angles. Vertically, when the two lines intersecting each other, vertically opposite angles are equal. This we have already know, right? So write down. And angle AOB is equal to angle COD. Why? Because they are vertically opposite angles, right? Okay. So side, angle, and then side. side, angle, side, right? So by SAS criteria, we can say that these two triangles are congruent, right? So therefore, triangle OAB is congruent to triangle OCD, right? By which criteria? Side, angle, side, right? Okay. The angle is the included angle, right? So the two sides which are equal sides, right? This is the angle between the two sides which are equal sides, right? So that's why this is the included angle. And the property criteria we are using to prove that they are congruent is SAS, right? Now, since these two triangles are congruent by CPCT, means corresponding parts of congruent triangle will be equal. By CPCT, we can say that angle BAO is equal to angle DCO, right? BAO, this angle, is equal to DCO, this angle. Getting that? Okay. So we have proved that BAO is equal to DCO by CPCT. Getting it? By CPCT. Right? But these angles are alternate interior angles. Yes or no? But these angles are alternate interior angles, right? So we have proved that alternate interior angles are equal for the set of lines AB, DC, which is cut by the third line CA. CA is behaving as a transversal, and we have proved that this angle is equal to this angle, which are alternate interior pair of angles, right? For this set of lines, we have proved that alternate interior pair of angles are equal. Therefore, we can say that AB is parallel to DC. Is that clear? Right? Therefore, AB is parallel to DC. Right? Now again, now we can consider the triangles OAD and triangle OCB. Right? Now which triangles we are considering? OAD, this one. Look at the figure, OAD, and triangle OCB, this one. Right? So same thing we will prove here also. Right? Okay? Getting it? So now in these two triangles, what we have? OA is equal to OC. This is already given. OD is equal to OB. This is already given. And angle BOA is equal to angle BOC. Why? Vertically opposite angle, right? Okay. So OA, this is equal to this. This is equal to this. And this angle is equal to this angle, right? So again, by SAS criteria, we can say that this triangle is congruent to this triangle. I hope you're getting this, right? Okay, so write down. Okay. By vertically opposite angles, right? Therefore, we can say that triangle OAD is congruent to triangle OCB by SAS criteria, right? So since these two triangles are now equal, means they are congruent, right? So can we say that angle ADO, this angle, is equal to angle CBO, this angle? Again, these two angles are the alternate interior pair of angles for set of three lines, which are AD and BC cut by the transversal BD, right? Okay, getting that. So write down. That from this we can say that angle ADO is equal to angle CBO by CPCT, right? But again, these are alternate interior pair of angles, right? Therefore, we can say that AD is parallel to BC, right? So what we have proved that AB is parallel to DC, and in the second one, we have proved that AD is parallel to BC, right? So from 1 and 2, we have AB parallel to DC and AD parallel to BC, right? So since opposite sides we have proved that they are parallel, hence ABCD is a parallelogram. So we have proved that ABCD is a parallelogram, right? So in this way, we have proved this theorem that if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Is it clear? Please note down. So now in this theorem, theorem number 6, prove that the diagonals of a rhombus bisect each other at right angles, right? So we have to prove that the diagonals of the rhombus, they are bisecting at right angles, means they are perpendicular to each other, right? So let's draw a rhombus. So what is given? First write it down. Given is a rhombus ABCD, right? And in this rhombus, AC and BD, the diagonals, intersect at point O, right? Okay. Now, what we have to prove? We have to prove that OA is equal to OC and OB is equal to OD, right? Okay. First, we have to prove that they are bisecting each other, right? The very first part. And in the second part, we have to prove that angle BOC is equal to angle DOC is equals to angle AOD is equals to angle AOB is 90 degree. Means this angle, this angle, this angle, these are all 90 degree angles. Okay, ये भी prove करना है, right? So what we have to prove? That OA and OC are equal, right? Similarly, OB and OD are equal, and they are bisecting, the diagonals are bisecting at right angles, right? So these are right angles. Okay, is it clear? Now, start the proof. For the first part, as you can see, the rhombus ABCD is a parallelogram. Yes or no? Rhombus is what? Rhombus is a parallelogram, right? ABCD is a parallelogram, right? So since this is a parallelogram, AB, BC, and this is a rhombus also, all sides are equal, right? For rhombus, all sides are equal. Are you getting that? So this, and this, all sides are equal to each other, right? Okay. And also, we know that, what we know, that the diagonals, now यहाँ पर आपको property का use करना है, right? Diagonals of a parallelogram bisect each other. This we already know. This is a property of the parallelogram, right? Okay. So diagonal of a parallelogram bisect each other, and rhombus is a parallelogram. Therefore, diagonals for this rhombus also will bisect each other. That means we can say that OA is equal to OC and OB is equal to OD, right? So since this is a parallelogram, the diagonals bisecting each other, and therefore for this rhombus also we can say the diagonals are bisecting each other. Now in the second part, we have to prove that these diagonals are bisecting at right angles. They are perpendicular to each other, right? So we will consider the triangles in triangle BOC and triangle DOC, right? So look at the triangle BOC, right? This triangle and DOC, right? In these two triangles, BOC and DOC, these adjacent triangles, this and this, right? In these two triangles, what we have? We have a OB is equal to OD, right? OB is equal to OD. This we have already proved equal, right? In the previous part, BC is equal to DC. BC is equal to this DC. This is already given because this is a rhombus, right? Okay. So these two sides we have already know. We already have in these two triangles that they are equal, right? And OC is the common. OC is the common side between the two triangles, right? And therefore these two triangles are congruent to each other. I hope you're getting this, right? So write it down that OB is equal to OD, BC is equal to DC, and OC is equal to OC. This is common, right? This is given. This is given. This we have proved and this is given, right? By part 1, right? So we can say that triangle BOC is congruent to triangle DOC, right? So since we have proved that these two triangles are congruent, by CPCT we can say that angle BOC is equal to angle DOC. ये दोनों equal होंगे, right? Okay, by CPCT, right? So write down angle BOC is equal to angle DOC by CPCT. Corresponding parts of congruent triangle will be equal. But we know that angle BOC and angle DOC are making a linear pair too. Yes or no? Their sum is 180 degrees. If you look at this, right? We have proved that this is equal to this. And they are linear pair also, right? Getting it? They are on both the angles are on the same line at the same point, right? Right? And they are linear pair, forming a linear pair, right? Okay. Means their sum is 180 degree, right? So BOC plus DOC is 180 degree, right? And both are same. That means we can say that angle BOC is equal to angle DOC is equal to 90 degree. That means each one of them is 90 degree, right? So we have proved that these two angles, BOC and DOC, BOC and DOC is 90 degree. Now, similarly, we will consider the other two triangles. We prove them they are congruent, right? And by congruent, we prove that angle AOD is equal to angle AOB and they are linear pair also, right? We will prove that this angle is equal to this angle and they are linear pair also. Therefore, this is also 90 and 90, right? So, in this way, we will prove that the diagonals are bisecting each other at right angles, right? So, write down. Similarly, I'm not writing everything again, right? So you can try it on your own. Similarly, angle AOB is equal to angle AOD is equal to 90 degree, right? Hence, so from 1 and from 2, from 1 and 2, we can say that diagonals of a rhombus bisect each other at right angles. So in this way, we have proved that diagonals of rhombus are bisecting each other at right angles. Okay. Yes, I hope you are getting this. Now, converse of this theorem, converse of theorem number 6, theorem 7, converse of theorem 6, right? That if the diagonals, of a quadrilateral bisect each other at right angles. Prove that, or you can say, if the diagonal of a quadrilateral bisect each other at right angle, it is a rhombus. Okay, so this is theorem number 7. So this is the converse of the above theorem. Okay. This is not done. So now to prove this theorem, first write down what is given to you, right? Like a quadrilateral is given, ABCD is a quadrilateral, in which the diagonals, suppose AC and BD, they are intersecting at a point, suppose O, and they are bisecting each other. So it is already given that the two parts of the diagonals are equal, right? Okay. And it is also given that they are perpendicular, means AC is perpendicular over AD. Now you have to prove that ABCD is a rhombus. So what you will do? So again, what you can do, you can prove that the triangles, the adjacent triangles, they are congruent, right? So as we have done here in this question, this previous theorem, that we have proved that adjacent triangles are congruent. Similarly here, we will prove that adjacent triangles are congruent, right? So once we prove that, right, we can say that the two sides of the triangles, like AD and DC, suppose this is a rhombus. I'm just giving you the idea, like you can try this on your own, right? Suppose this is a rhombus. Okay. And we have two diagonals here. Okay. Right. So ABCD is a quadrilateral. It is given. So what is given? Given here ABCD is a quadrilateral. Right. The first thing. And in this quadrilateral, the diagonals AC and BD, they are bisecting each other. Means, suppose this is O point, means OA is equal to OC and OD is equal to OB. Okay. Getting that? And these two diagonals are perpendicular to each other. Means AC is perpendicular over BD, right? Means they are forming a 90-degree angle here, here. This is all 90 degrees. They are perpendicular to each other. This is already given. Now, what we can do is, we can prove that this triangle and this triangle are congruent, right? AOD and COD are congruent, right? Okay, how you will prove? See, OA and OC are already given equal, right? Angle AOD, this angle and this angle is already 90 degree, both angles are right angles, right? And OD, this line is common to both the triangles. That means these two triangles are congruent to each other. And once we have proved that these two triangles are congruent, we can say that line AD, the side AD is equal to side DC, right? Okay. Similarly, we can prove the other two triangles, the two adjacent triangles, they are congruent. And from there, we can prove that AB and BC are equal, right? Okay. And you can take any this pair of adjacent angles triangles also, and you can prove that AD and AB are equal, right? So in this way, you can prove that all sides are equal to each other, and therefore this is a rhombus. Okay, are you getting this? How to do? Yes or no? So just try it on your own.